In this chapter, we will study about the basics of refraction. Refraction is closely related with the speed of light. The speed of light is different in different medium, but in air, the speed of light is maximum. When the ray of light travels in air medium, very nearly we consider air as vacuum, but air and vacuum are different, but still the speed of light in vacuum is considered to be 3 into 10 to the power 8 meter per second. The speed of light in air is considered to be 3 into 10 to the power 8 meter per second. That means equal to vacuum, though the speed of light must be reduced to some extent in air, but for sake of our convenience we consider it. Whenever light travels in air, it travels in a fixed path, but while it enters into another medium, it bends from its normal path. This is the ray of light traveling in the air medium and at the separating surface. At the separating surface of another medium, while it travels in another medium, this is the actual path, but it bends from its normal path. It bends from its actual path. Now, at the point of incidence, if we draw a perpendicular line, this is called normal. This is called normal. The angle made by the incident ray with the normal is called angle of incidence, and the angle made by the refracted ray with the normal is called angle of refraction. Now see, this is the actual path of light ray. It has bent towards the normal. It is traveling from, let us consider, in air to any other medium. It may be glass or water. Now, whenever light travels from one medium to another medium, its speed changes. Because of change in speed, it cannot follow the same track. It must get deviated from its original path. This deviation of light ray at the separating surface, while it travels from one medium to another medium, at the separating surface, it starts bent from its original path while traveling in the second medium. Not the entire light, but a part of the light, and the other part of the light gets reflected in the same medium. And this bending of light while it travels in the other medium is called refraction. So what is refraction? When a ray of light traveling in a homogeneous medium falls obliquely at the separating surface of another medium, while traveling in the second medium, a part of the light ray gets deviated from its original path. This bending of light at the separating surface while it travels in the second medium is called refraction of light. Now here it will come very often with two words. One is optically rarer medium and another is optically denser medium. See, physical density and optical density are completely different. Physical density is mass per unit volume. That means how much mass is contained in a definite volume will give the density of that particular substance. But here we are considering optical density. Now, how can you define optical density and what is optically rarer medium and optically denser medium? Whenever a ray of light, while traveling in a particular medium with a definite speed, enters into another medium, its speed changes. Not often. Its speed changes. If the refractive index of the two medium are different, its speed will get changed. Now, if the speed decreases, then this medium is said to be optically denser as compared to this medium. But if the speed increases in this medium will said to be optically rarer as compared to this medium. Since the speed of light is maximum in vacuum or air, so air is the rarest of the rare medium. That means whenever a light ray travels from air to any other medium, its speed will get decreased. So optically rarer means where the speed of light decreases, and optically denser medium means the medium where the speed of light decreases is called optically denser with respect to the first one. Now there are two laws of refraction. So what is the cause of refraction? The cause of refraction is due to the change in speed of light. Now there are two laws of refraction. Number one, the incident ray, the refracted ray and the normal at the point of incidence lies on the same plane. And number two, the sine of the angle of incidence bears a constant ratio with the sine of the angle of refraction. Now you are reading in class 8, so sine of the angle of incidence means sine I. Sine is a trigonometric ratio. Sine of angle I by sine of angle R is called refractive index. Now we can also define refractive index in this manner. Refractive index of the second medium with respect to the first. In this way we say refractive index mu, Greek alphabet, of the second medium with respect to first. That means speed is traveling from first medium to second medium. We are saying that the refractive index of second medium with respect to first is speed of light in first medium by speed of light in second medium. Now if the first medium is vacuum, the speed of light in vacuum is considered to be c, and speed of light in the second medium is considered to be v. Now speed of light is maximum, so we can say that c is greater than v, whatever the value of v. v টা তোমার তুমি গ্লাসেও ধরতে পারো, ওয়াটারেও ধরতে পারো, যে কোনো মিডিয়ামে ধরতে পারো, কিন্তু স্পিড অফ লাইট এয়ারে বা ভ্যাকিউমে ম্যাক্সিমাম, তাই সি সবসময় ভির থেকে বড় হবে, ভি যেই হোক না কেন। সি তো ভেলোসিটি অফ লাইট ইন ভ্যাকিউম, ক্রস মাল্টিপ্লাই করলাম, সি বাই ভি গ্রেটার দ্যান 1। আবার সি বাই মি মানে কি, মিউ, মিউ is greater than 1. So this is called absolute refractive index. When the first medium is considered to be vacuum, then this ratio is called absolute refractive index. It is considered as mu. Mu is equal to c by v. So the speed of light in vacuum is 3 into 10 to the power 8 meter per second. Now if you know the speed of another medium, then you will be able to find out the refractive index of the second medium with respect to the first medium. Now refractive index is very important because it determines how the light will behave in while traveling in another medium. So refractive index in another way we can say that it is a constant term, but still it determines how much the light will bend while traveling from one medium to another medium. Now there are several consequences of refraction of light. We will discuss it in our later class.